Assalamualaikum warahmatullahi wabarakatuh and very good morning to everyone. Today I will present my paper titled as NodeMCU-Blynk Integration, Cultivating Remote Control and Monitoring for Peace Lily, Spathiphyllum Plant Growth and Health. Nowadays, indoor gardening has gained significant popularity in recent years due to the increasing urbanization and limited outdoor space available for traditional gardening. This trend has been fueled by the desire to bring nature into living spaces, improve air quality, and enhance the aesthetic appeal of homes and offices. Indoor plants such as peace lily not only beautiful interior but also offer numerous health benefits, including stress reduction and air purifications. Despite its advantages, indoor gardening presents unique challenges. Indoor environments often lack the natural condition necessary for plant growth, such as soil moisture level, humidity, and temperature variations. Consequently, indoor plants require careful monitoring and precise care to thrive. For novice gardeners, this can be daunting as they must understand and manage these specific requirements without the benefits of outdoor cues. So, the advancements in technology have led to the development of smart plant monitoring system which offer innovative solution to the challenges of indoor gardening. A bit knowledge about peace lily. Peace lily are popular indoor plants known for their lush foliage and ease of care. However, their optimal growth is dependent on the specific environment condition, including temperature, humidity, soil moisture, and soil type. The ideal range for peace lily to growth for humidity is around 60% to 80%. For temperature is around 18 to 30 degrees Celsius. For soil moisture is around 40% to 70%, in which if we convert into ADC value, analog to digital conversion, it's around 300 to 700, or by naked eyes, the moisture of soil should be moist but not waterlogged. For type of soil, it is favorable to have superior drainage capabilities. So in this paper, there are three problem statements, which is the first one is novice gardeners often struggle with the complexity of watering and monitoring plant health, which can lead to improper care and poor plant growth. Second is manual irrigations can be inefficient and unreliable as it is difficult for the gardeners to consistently maintain the right soil moisture level for their plants. And the third one, gardeners lack the ability to remotely monitor and control the environmental condition of their indoor plants, limiting their ability to ensure optimal plant care. So, from the problem statement, three objectives have been developed, which is the first one is to help novice gardeners manage the demanding task of watering and monitoring plant health. Second is to make the irrigation process easier and more efficient, providing comprehensive plant health monitoring and empowering users to make data-driven decisions for the well-being of their peace lilies. And the third one is to wirelessly transmit the collected data to a mobile applications, which is Blink application, allowing users to remotely monitor the plant's conditions. So for the project overview, this project utilized NodeMCU and Blink application to automate the care of peace lily, ensuring that they receive the optimal amounts of water and maintaining ideal growth conditions. The project integrates sensors to collect real-time data on soil moisture, temperature, and humidity, which is transmitted wirelessly to Blink applications for remote monitoring. So the irrigation system is controlled based on the soil moisture level, where when the soil is detected as dry, a notification alerts the user to activate the water pump via Blink applications. So this system was tested over a period of 5 weeks on two different type of soil, which is black soil and compost soil, using the same setup. Next, the methodology for the system design. It is used NodeMCU-ESP8266, which is used as the microcontroller for the system, and it will gather the data from the various sensor. Next is DHT11 sensor. It is used to measure the humidity and temperature surrounding the plants. The third one is soil moisture sensor, which is used to measure the moisture content in the soil, and also provide the data to NodeMCU to determine the watering. And then the fourth one is water pump and relay, which is used for the irrigation process, which controlled by the relay. And last is Blink Applications, which is a platform for monitoring and control system. So the working principle for the DHT11, it operates based on the principle of capacitive sensing and temperature sensing. This component measure the humidity through the capacitive humidity sensor, where when the component absorb the moisture from the air surrounding, it makes the resistance in the component decreases. So it is also measure the temperature using the thermistor. So when the component detect the temperature as high, the resistance in the component is decreases. So the accuracy of these components for humidity is plus minus 5%, and for the temperature is plus minus 2 degree Celsius. The working principle for the soil moisture sensor, it operates based on the principle of capacitive sensing. It measures the moisture by measuring the dielectric content of the soil. So when the water content in the soil is high, that means it has high capacitance. And if the water content in the soil is less, it means low capacitance. So the analog voltage signal, which is the output from the sensor, is then fed into the analog to digital conversion, which is known as ADC, of the NodeMCU ESP8266, which convert it into a digital value ranging from 0 and to the 1023 value. Next, methodology for the experimental setup. So this system has been experimented for over a period of 5 weeks by comparing the system performance on two different type of soil, which is black soil and compost soil. So the purpose was to compare the outcomes for the plants using the same system. So in this system, it is used to monitor the soil moisture level, temperature, and humidity to observe the conditions for peace lily to growth. And then for the irrigation system, it is controlled based on the soil moisture level, where when the soil moisture sensor detect the moisture level more than 700 uh, value of ADC, a notification will be pop up to alert the user to activate the water pump from the Blink applications. So when the water pump is activated, the water will be flow and will be automatically turned off when the value of soil moisture less than 700. Next, for result and discussion, in this slide, there are two tables that represent a comprehensive overview of the parameter measured using the design system for both type of soil. So the data was collected from May 17 to June 16. So in this table, there are column for temperature, humidity, soil moisture level, and also irrigation. In the irrigation column, there are value of 0 and 1, where the value of 1 indicates that the water pump is activated due to the low soil moisture levels, while a value of 0 indicates that the system solely monitored temperature, humidity, and soil moisture without activating the water pump. So from the table just now, the data has been analyzed based on soil moisture and humidity. So in the soil moisture graph, the blue bar represent soil moisture level for black soil, while the orange bar represent those for compost soil. So in this chart, it provides a clear comparison of how soil moisture fluctuates over the observed periods between these two types of soil. So from the experiment, we know that when the bar reached a value of 700 and above, it indicates that the soil moisture level is dry. So at this point, a notification is sent through Blink application. So at the range of 700, we can see that the blue bar, which is the black soil, have eight irrigations happen between the experimental period, while for the compost soil, there are seven irrigations happen. So we can conclude that black soil dry faster compared to compost soil. So for the humidity chart, uh, we can see that the majority of the recorded data falls within the ideal humidity range for peace lily, which is typically range between 60% to 80%. So we know that in Malaysia, however, the humidity level can fluctuate between 74% to 86%. So, but uh, peace lily still can thrive because they prefer high humidity over high temperature. So, as a conclusion, overall, the system has proven its effectiveness in maintaining ideal growth conditions for peace lilies, with black soil being the better choice for optimal plant health. Regarding humidity and temperature, despite Malaysia's climate occasionally exceeding the ideal range, the system effectively monitors soil moisture, ensuring timely watering to support plant health. Therefore, this experiment is deemed successful for smart plant monitoring applications, demonstrating its potential utility in optimizing plant care practices. That's all from me. Thank you.